that is driver and monitor should be implemented as a transactor. So we know that drivers and monitors are verification components, so they will take a transaction as a input and give you physical level signals. Although a different label is used to refer to command transactor from functional layer transactor, they only differ in their interfaces. Okay, so interfaces mean they are talking about the physical interfaces. The high level interfaces on the both side of the transactor is a transaction level interface, so they are talking about the procedural interface. Okay, so transaction level interface means that will communicate to the verification environment. Physical interface means that will communicate to the DUT. So the low level interface on the command layer transactor is a physical interface and is designed to connect to the DUT. So this is the basic thing. On a functional layer transactor, the low level interface is the transaction level interface, which is designed to connect to the high level interface of the another transactor. So this is we know that this is the responsibility of bus function model. So in all other respect, the command and function layer transactor operate in the same way as should be implemented using the same technique and offer the same type of capabilities. Okay. Now coming to the next point, a monitor transactor should be configurable as a reactive or a passive. So when you are implementing a monitor, okay, either you should configure the monitor in the reactive mode or a passive mode. What they are trying to say is you should model a generic monitor, okay, but based on your test case you should able to configure that monitor either in reactive mode or in passive mode. So instead of using two separate monitor, it would be easier to maintain a configurable monitor because of functionality can be shared between the two flavors. So that is what I told you, like there should be a configuration, okay, like you can use a switch, okay, or you use a parameter in order to configure the monitor in active mode or a reactive mode or a passive mode. Coming to the third layer of the verification environment, that is functional layer. So what is the responsibility of functional layer? So before that we have seen the example of the USB, right? So there we have seen firmware, scoreboard and USB transfer type will come in function layer. Okay, so we'll see what all the responsibilities of firmware and scoreboard and transfer types in functional layer. So the function layer provide the necessary abstraction layer to process the application level transaction and verify the correctness of the DUT. So if you are verifying the DUT at function layer, means you are verifying in terms of transactions. Okay. So unlike interface based transaction of the physical layer, the transaction in the functional layer may not have one-to-one correspondence with an interface or physical transaction. So if you are performing verification at function level, okay, so during that time there should not be a one-to-one correspondence, like whatever is there on the physical pin, same will come on the physical interface of the BFM. So that is one-to-one correspondence, but that is not possible in terms of functional transactions. So functional transactions are abstractions of the higher level operation performed by the major subset of the entire duty beyond to the physical interface module. So if I will take an example, you take example of the USB. So USB, what type of transfers are there? Control, bulk, interrupt and ISO. So if we are performing verification at that level, okay, at that abstraction level, then we can say that this is a function level verification. So a single functional transaction may require execution of dozen of command layer transactions on a different interfaces. So definitely your function layer will communicate to the command layer on the one side and scenario layer on the other side. Okay, so you have to manipulate many of the tasks. Okay, it may depend on the completion status of some physical transaction or retry some transactions or delay others. Okay, so this is what you need to implement in the function layer transactors. Okay, now so you see here, so abstraction of sub layer to easily create a relevant scenarios and corner case for that level of abstraction. So you can easily create corner cases at this level of transaction. Okay, so this is the Ethernet MAC. Okay, so here they will talk in terms of physical, then you are giving IP fragment over the Ethernet, so then IP fragment reassembling, then you are reassembling, and TCP IP. So after that you are giving the data to TCP IP. So in this way how they are abstracting the